Hello friends, welcome back. In this session, we are going to discuss why deep learning, what is the difference between deep learning and machine learning from its functional perspective, as in why do we need the transition that has to happen from the machine learning to deep learning, and we are going to also understand the application sectors and the possibilities for deep learning. It's going to be an interesting session and it's going to be easy for us to understand as well, and the agenda is pretty clear. We'll have a quick introduction first and then we'll go deeper into the content. Now, in the recent past particularly, the artificial intelligence and the machine learning have been the buzzwords, and this is very quickly picking up for the past 2-3 years, though the interest has been climbing up for the past 10 years. Almost for the past 1 decade, we have been seeing that there is a growth in artificial intelligence. The computational speed and the availability of a large amount of data that has really provoked the researchers and the academicians to think and to unleash the research potential in the deep learning and the machine learning sector. Machine learning helped us to start, but deep learning is the destiny. Deep learning is where we are getting tremendous potential really revealed, and we can build applications that are really amazing with machine learning. It's with deep learning. It all started with machine learning and it navigates to deep learning. Deep learning architecture is built in a very similar way of the human brain functionality. We are mimicking the human brain and we are getting the results as close as possible to the human brain whenever we go for deep learning. Deep learning is all about neurons, deep learning is all about neural networks, and hence we can get the performance which is pretty close to the human brain. This definitely is tedious, this definitely is going to be complex, and this is a challenging task to build deep learning algorithms, but it should not be taken as the negative phenomena, and this should be taken as a challenging phenomena. We are trying to build a system as close as the human brain, and that's what deep learning is all about. Well, we have got multiple layers in the neural nets in the deep learning, and its ability to auto adapt, its ability to learn has actually been really amazing. The efficacy of deep learning algorithms are nowhere in comparison with the traditional machine learning algorithms. We have the deep learning algorithms grown somewhere superiorly high when you compare it with traditional machine learning algorithm, and the application sectors are really tremendous and really vast. We have got the natural language processing, the speech and the image recognition, entertainment sector, online retailing stores, banking and finance applications, automobile sectors, chatbots, most importantly, the recommender systems, the voice assistants to self-driving cars are some of the real cool applications that somebody can think of when we think about the deep learning. All these are really very good, and the way the applications have been developed with deep learning and the way someone can get very interactive as well as very real-time performance with deep learning is amazing. Now, the next point is the need for deep learning. Right, you can see two cars that I have kept as pictures right there in the top. One is MG Hector and another one is MG Gloster, and both of them are called internet cars, and the Gloster has been little advanced with lot many self-driving features. So we need deep learning to enjoy all these kind of real cool features. We cannot imagine something we cannot imagine our home without the Google Home or Alexa or Siri or Cortana. We cannot imagine that world in next few years without these supporting features, supporting software and the elements that are available for us. It's going to be pretty useful for us. It's already useful for us, and we are seeing that the old age people even using the Google voice search to search results which they want to find out with. And the shopaholics, all of them are shopping online these days, and without online shopping they are not able to even think about their shopping, and the online shopping is no way possible without deep learning and machine learning into picture. Deep learning is used most extensively in online shopping, and the suggestions that you get and the recommendations that you get from these kind of deep learning applications for the online shopping is really cool. And now coming to the next thing, automatic driving or self-driving cars like MG Hector, Gloster, the advanced cars like BMW, Audi, and other superior cars have been having all these features nowadays. Even the smallest and the lowest version of the cars have a lot of features that are enabled through deep learning, like advanced driver assisting systems are enabled through deep learning, the camera based systems are enabled through deep learning. It comes even in a car which is of a normal level, which is of 8 lakhs 9 lakh rupees in Indian rupees. You get a car which has got all the features, and thanks to deep learning for that. The MG Hector and the Gloster cars, if you see, they've got automatic parking facilities. It's almost like phenomenal features that have been developed through deep learning support. Though they are expensive, the features are really cool. And we are using smartphones, smart homes, smart electrical appliances. All those things would become impossible without having deep learning in picture, and hence we need deep learning. We are married to deep learning for the technological advancements. Right. Now the question would be, what is the need for the transition from machine learning to deep learning? Machine learning has been around for a long time, right? It's around 15, 20 years people are talking about machine learning, and machine learning has helped and motivated scientists, researchers, academicians to come up with multiple newer algorithms, and that is actually cool. But the major limitation is there in machine learning, where we need to explicitly have the human intervention for extraction of the features. That's very, very important. You need to write code, you need to devise algorithms for getting this extraction of the features done. But deep learning helps you and enables you to extract this feature as automated feature extraction, and the algorithms itself, the deep learning modules itself, the models itself will be able to extract, and it can all be done by itself. So the major difference is this dynamism. So we can see a simple example here with the picture, where you can see that in the left hand side I have got an Apple image, and I need to write code for feature extraction. I'll then go for learning, and it is recognized as Apple when it comes to machine learning. But when it goes to deep learning, it is all automated, I mean automatic feature extraction and learning, and then our algorithm gets it recognized as Apple. This is the major difference that one could cite between the machine learning and deep learning, and the reason for the transition is this. But otherwise, deep learning is superior in all aspects, right? Deep learning is always complex, people say, and deep learning always imitates human brain and biological neurons, and that's why it remains complex. But please do not see it as negative. The human intelligence is the best intelligence that someone could ever compare anything with. So we are trying to bring it to that level, and hence it looks complex. But again, it is required, and it is going to be much more better in near future as well, where we are going to get most complex systems that are going to help us out with deep learning. And applications are quickly going to be looked in right now, and we are going to spend about next 5 minutes for getting the clear understanding about some of the quick applications that you would all understand. Self-driving cars. The Uber, Google have been researching and developing autonomous cars, and we have heard a lot of news about Tesla automated cars as well. I mean Tesla autonomous cars as well, which are pretty successful. And in next few years, you could see in Indian roads even that these self-driving cars will go. MG, as I told you some time back, has already rolled out the cars in the market, and MG Gloucester and MG Hector have been already using a lot of internet into their cars, and it's going to be pretty amazing in near future as well. And ADAS is advanced driver assisting systems, which I have already dealt about in a lot of my videos. They are going to be pretty useful, and they are built completely out and out through deep learning. And DMS is driver monitoring system, which is also built through the deep learning systems. The support systems which are available from the sensors like the radar, the camera, and multiple other sensors available these days, which are very smaller in the form factor as well, is going to help us out in getting multiple features which are going to be added to the self-driving cars. The next is emotion detection, the pose estimation. We have a lot of applications that are being developed in the sector of emotion detection, pose estimation. You can see that one such application has been demonstrated here. I'm estimating my own pose here, and here you can see that I am understanding the emotions of self. You can see that I'm this much percentage neutral. I'm not happy here because I'm showing an angry emotion, and surprise is there, sad is there, and anger is the prominent emotion here. So we are able to estimate the emotion and pose all these through deep learning, and this area is too cool for somebody to work with. And natural language processing and the recommender system is something amazing, which is growing at a very fast rate. You can see that Google translators are all pretty helpful for us, and you can see that in English I have typed hi, how are you, and in Tamil I get a reply immediately as hi, நீங்கள் எப்படி இருக்கிறீர்கள். This is pure Tamil, and here you can see that I have got the same thing in Hindi as well. So all these are possible, all these are getting real time and enormously responsive, and all these are possible because of deep learning. And you can see that the recommender system is also helping us out in recommendations towards completion of our queries. There are multiple recommender systems available, like recommendation for the products, recommendation for the research papers that you are searching for, and this is a cool area for research. And auto captioning in YouTube is one of the very important areas that I would like to highlight, which is one of the core applications of deep learning. You can see that when I talk in my videos, this is one of my videos in YouTube, and when I talk, automatically the captioning is coming, and this is an amazing progress through deep learning, and this is a wing of NLP that one could easily see. Healthcare, I have built a lot of systems, and I have demonstrated that in my innovative projects, where you can understand how healthcare products can be built with deep learning. We can understand if a person's lung x-ray reveals COVID-19 presence there. We can also understand if there is cancer or not through the skin cancer or not through the skin x-ray, skin images, and all this have been done already, and there is a lot of scope for development in this sector, and it's going to be an amazing area to work. Multiple researchers are working on healthcare related deep learning applications, and that's one of the areas. Though there are a lot many areas that are available, I felt that these are the prominent areas for somebody to start with, and the transition has to be understood, the need has to be understood. That's why I kept the session. I hope you like the session, and in case you have any questions, suggestions, please go ahead and type in the comment sections. I'll be happy to answer it. Thank you for following the channel. If you like the channel, the content, please give a thumbs up and subscribe. Thank you.